Hello, welcome again to Kim's Bio Production Academy. I do like more of paperwork, more of writing. So today we are discussing about the factors affecting enzymes, and I'll be doing this in terms of illustration form, then much of explanation. As you understand, we have around 5 factors that will be affecting enzymes, and those, when we list, there will be temperature. That is one. Number 2, you'll check we have enzyme concentration, we have substrate concentration, we have enzyme inhibitors, we will have pH, and the last one, we have cofactors and coenzymes. But let's first key with these main key ones, which will be the temperature. When we sketch about the temperature, this one will be a temperature in decrease. This one is a independent variable, but this one is the dependent variables, which will be the rate of reaction. So as we plot, you can check how the graphical representation will be like. At B, so I've listed into some 3 parts, that is A, B, and C. And when you check A, B, and C, at B, it will be our optimum point. So this one can be our optimum temperature. Then this other section will be our optimum rate of reaction. So when you're explaining, you'll explain in 3 divided sections, or even you can make it 4, of which the first one will be at A. When you check at A, our temperature is low. At A, we are saying our temperature here is low. So because of the low temperature, what happens? The rate of reaction, you can check even is still low. That is where you can be awarded a mark. And because of this one, this is because enzymes, when it's low temperature, enzymes are inactive. And because of the inactive nature of the enzymes, their the enzymatic action will also be low. We have said that A, the temperature is low, thus low rate of reaction. You get a mark? Because of enzymes are inactive, which lead to low enzymatic action. Then you'll be told, maybe explain the rate from A to B. When you check your temperatures, you increase your temperature from point A to point B. That is increased from this point to this point. What happens? The rate of reaction increases rapidly. And this is increasing rapidly. The main reason is because we're increasing the enzymatic action. So when you check at this point, we are speaking about increase in temperature from point A to B. The rate of reaction increases rapidly. And this one is because enzymes at this point have been activated. Enzymes have been activated. Thus increase in the enzymatic action. That is your end result of explanation. Then from B, C, because before the B, C, let's check at B. And at B, what is happening here? This one is our optimum temperature. At B, we are speaking about what? Optimum temperature. And because of this one, the rate of reaction is very high, not just high, but very, very high. And this is because most of the enzymes are working best at this point. Enzymes are working best and very high enzymatic action. So from this point now, we go to B and C. And when you check from point B and C, you can see there is a drop, right? So there is a gradual decrease. So you'll check about further increase of temperature. We don't have high temperature, it's high temperatures above optimum. So as we increase our temperatures from the optimum point, what happens to the rate of reaction? The rate of reaction starts to decrease gradually. And the main reason we're speaking about the optimum temperature, further increase, that is at B and C, further increase in temperature above optimum, right? The rate of reaction starts to decrease gradually. because enzymes have been denatured, leading to the decrease in the enzymatic action. So for you just to respond about the temperature, well, you just have to understand this key summary here. We're speaking about low temperature, increasing your temperature, optimum temperature, and above optimum temperature. When the temperature is low, enzymes are inactive. When you increase, you activate your enzymes. At optimum, your enzymes will work best, and above optimum, you'll denature your enzymes. That is much about the temperature. So let's go back again and discuss about what? Let's discuss about the enzyme concentration. When you check, you have flow chart here. You can check the enzyme concentration and your rate of reaction. And when you check about the enzyme concentration and substrate concentration, they have a correlation. Both are first increasing, that remains constant. Still, this one increases, remain constant. When you're explaining enzyme concentration, you give explanation based on substrate concentration. And the reverse is, when you're discussing substrate concentration, you give an explanation based on enzyme concentration. Let's check about that. So this one is your enzyme concentration, right? From point A and B. No, let's start first at A. When the enzyme concentration is at A, that means it's low enzyme concentration, right? The rate of reaction is also low. The main reason, I've said use substrate, the main reason of because of low substrate concentration and low enzymatic action. At A and B, you're increasing your enzyme concentration, so it's like increasing your active sites of your enzymes. The rate of reaction increases, it's increasing rapidly, right? And the main reason why it's increasing rapidly, because of increase in the substrate concentration and increased enzymatic action. Then these B and C, you further increasing enzyme concentration, so you're increasing more active sites of the enzymes. What happens? The rate of reaction is remaining constant. Why is it remaining constant? Because all our substrate have been acted, or you can speak about they have been broken down by these enzymes, right? So you can be told, how can you increase from this point where it has started to remain constant? You increase that substrate concentration. You increase what? Substrate concentration. Let's read. So we are speaking about A at A. What happens at A? There is what? Low enzymatic concentration. That's low rate of what? Reaction, because of low substrate concentration. That's low what? Enzymatic what? Action. That is what I've said, right? Then at end B, you are speaking about you are increasing what? You are increasing the enzyme concentration. And because of this one, the rate of reaction increases also rapidly. And the main reason because of the increase is because of the increase in what? The substrate concentration, thus increasing the enzymatic action. At B and C, further increase in enzyme concentration, the rate of reaction remains constant, right? Because all substrate, we have said, they will have been acted by the enzymes. Let's now go to the final one, which is about the substrate concentration. I said earlier, when you're dealing with this one, you explain based on the enzyme concentration. And how will you explain on the enzyme concentration? You deal with the active sites of the enzymes. So let's check about this. The substrate concentration at this point, you can check it's low, right? Substrate concentration is low. The rate of reaction is also low. Low substrate concentration, low rate of reaction. Why is it low? Because of few active sites of the enzyme, because of low concentration of the enzyme. That's what we're speaking about there. From this point to this point, you are increasing. Why are we increasing? We're increasing the substrate concentration. What happens to the rate of reaction? The rate of reaction is increasing rapidly, right? So why is it increasing? Because we are increasing the active sites of the enzyme. That is the enzyme concentration. Further increase from point B and C. We are increasing the substrate concentration from B to C. So this is what we're speaking about. And when we're increasing this one, what happens? The rate of reaction is remaining what? Constant. Why is it remaining constant? Because all the active sites of the enzyme have been occupied by the substrate. So it means there is no enzymatic action taking place here. How can we increase from B? You increase your substrate concentration. Let's check about this. We are speaking about at A, substrate concentration is low. Make that. And because N's low rate of what? Reaction. And the main reason this is because of few active sites of the enzymes, thus low enzymatic action. I think that's what I've said, right? At A, substrate concentration is low, hence low rate of reaction. This is because of few active sites of the enzymes, hence low enzymatic what? Action. Then at A and B, so that is this point to this point. What is happening at that point? Increase in your substrate concentration. From this A to B point, the rate of reaction increases rapidly. And the main reason because of enough active sites of the enzyme. That's what I'm saying. You're increasing your enzyme concentration. That's why you're increasing the active sites. This increases the enzymatic what? Action. Then from point B and C, I've said further increase. That is B and C. You are further increasing the substrate concentration. What happens? The rate of reaction remains what? Constant, right? And the main reason this is because all the active sites have been occupied and no enzymatic what? Action. Then I've told you, how can you increase from this point to B where it has remained constant? You increase the substrate concentration. So on our next discussion, we'll discuss about the pH. But about the concept of pH, let me summarize briefly. You understand about enzymes are pH specific. And because of the pH specific nature of the enzymes, they can only work under very narrow pH range. A very narrow pH range from the optimum point. I can use an example. In the alimentary canal that is in the stomach, we have the pepsin and the renin. Those enzymes work under acidic condition, have a pH maybe optimum of 2, so maybe 2.5 or even 3 to 1.5. That is the very narrow pH range. That is the only point that they can work best. Anything away from the optimum point, the enzymes will be denatured. Thank you very much. As you wait, I upload another new series of concept. Thank you very much.